I'm Semasaka Kirendens. So I'm going to take you through a lesson in physics. And so today we're going to look at Newton's laws in their basic form. And so we go straight into the lesson. As I indicated, today we are going to look at actually Newton's laws, but first of all, we'll look at what actually force is. Well, force is merely a push or a pull which is exerted on an object. So if you want to move an object, you exert a force, meaning that you apply actually a force. So a force is merely a push or a pull exerted on an object. Well, force is a vector quantity because it has magnitude, which is also known as size, as well as direction. And the units which are used actually to measure force are newtons, denoted by the capital letter N. Or it can be actually kilograms, meters per square second, because mass would be measured in kilograms, while acceleration would be measured in meters per square second. In other words, what we are saying is that force is given by this formula: mass multiplied by acceleration. So as I indicated, force would be measured in newtons, while mass would be measured in kilograms, and acceleration would be measured in meters per square seconds. And therefore, this is how you get these units. And so, examples of force, we can represent force actually in a tension. That is a force that is produced by a stretched rope. If you are pulling something using a rope, in that rope there is force, and that force is known as tension. Another type of force is actually a force which normally opposes the motion of the force, which is known as friction. Well, there are two types of friction. One of them is known as sliding friction, which is actually a friction produced by an object which is sliding on another object, and therefore this object actually is moving. And there is another type of friction which is known as static friction. Actually, two objects which are in contact and they are not moving relative to each other, there is actually a type of friction which is known as static friction. So sliding friction is for an object which is sliding on another material, while static friction is a friction or a type of force which is produced for two objects which are actually in contact and they are not moving. Another type of force is actually upthrust. When you put an object in a liquid, at times the object, depending on the density of the liquid, it will float. So meaning that that liquid actually exerts a force upwards, and that force is known as upthrust. It's a force exerted by a liquid which is floating. And then we have another type of force, which is known as weight. Weight is actually a pull of gravity. That is, every planet has actually a force which enables the objects to go towards it, that is, to settle towards it. And so this weight is different in different planets. And what we notice that all these types of forces, they will be measured in newtons. Similarly, sliding friction will be measured in newtons. Static friction would be measured in newtons. Force is merely a type of friction. Upthrust would be measured in newtons. Weight would be measured in newtons. And so when you exert a force on an object, there is always an effect. Something happens. At times, the size of the object actually will change depending on the force that you apply. And at times, it changes actually the shape of the force, of the object, as a result of the force that you exert. Also, the object might change configuration. It might actually, if it was stationary or it was at rest, it might start moving. Or if it was already moving, it can actually increase its speed and therefore attaining acceleration. Also, it can also change the speed. It can also change the direction. So these are the effects of a force. So a force, when it's exerted, it produces a change in size, change in shape, change in configuration. An object which is stationary might move. It can accelerate, or it can change the speed as well as direction. What is an unbalanced force? Well, when forces on an object are actually not balanced, they result into a net force. In other words, what I mean is that if you have an object, you exert a force, force 1, say this is 20 newtons. Another force, force 2, which is actually 10 newtons. And on the other side, you have force 3, which is actually 25 newtons. So you notice that the net force here it will be equal to, you add the forces in one direction, force 1 plus force 2, and then we can subtract the force in a different direction, which is force 3. And therefore, what we get is 20 plus 10 minus actually 25. And you notice that you're going to get actually 5 newtons. So the net force would be 5 newtons to the right. And so we are saying when forces on an object are not balanced, we see here, these forces are not balanced, they result into a net force. And this unbalanced force, so the unbalanced force, the 5 newtons that we found, which is also known as unbalanced force, It is also known as the resultant force. So an unbalanced force is actually a net force, or a resultant force, or an unbalanced force. And so examples of resultant force, for example, if this is the x-axis and this is the y-axis, and we have two forces actually, starting from 0. So this force is 4 newtons along the x-axis, and another force, which is 3 newtons along the y-axis. So if you are to find the resultant force, as we know, when you are adding vectors, you add them from head to tail. This is our tail and this is our head. So this will be 4 newtons. And then we have this force, which we should add here, which is 3 newtons. And therefore, we can find the resultant. So the resultant, we can use Pythagoras theorem, which will be equal to resultant squared plus 4 squared plus 3 squared, which gives us actually 16 plus 9, which is actually 25. And therefore our R is equal to the square root of 25, which is equal to 5 Newton. Therefore, our resultant is 5 newtons. So this is really how we calculate the resultant force. Another example of a resultant force is, as I indicated, if you have one force, force 1, which is 50 newtons, and we have force 2, which is 25 newtons, and we have to find the resultant. This is straightforward. So our resultant will be actually 50 newtons minus 25 newtons, which gives us 25 newtons. To the right. You notice that here we are giving direction. Similarly, even here, we can actually get the direction of this resultant by saying that actually tan theta is equal to opposite over adjacent, which is equal to actually the opposite, which is actually 3 divided by 4, which we can actually get now the angle by saying tan inverse of actually 3 over 4. And then we can get the angle. So we have elaborated here how actually we can get the resultant force. And so now we go to define Newton's laws. And we start with the Newton's first law. According to Newton's first law, it states that actually an object, at least if an object is not moving, it will remain stationary, or if an object is moving, it will continue moving with the constant velocity unless it is acted on by an external force. So an object actually which is moving, it will continue moving at constant velocity unless there is an external force which comes to act on it. Or if it's at rest, it will remain at rest unless it's actually acted on by another force. And so actually, Newton's first law actually implies the state of inertia, that objects actually which are moving, they would want to remain in that state of motion. And if an object is stationary, it would want to remain in that state of rest, according to actually inertia. And so the explanation here that if the forward forces and backward forces cancel out on a stationary body, then the object will remain at rest. In other words, what we are saying is that if the forward force is 10 newtons and the backward force is 10 newtons, it means that this object actually will remain stationary because the forces cancel out. Because when you get the resultant, it will be actually 10 minus 10, which is actually 0. The other explanation is that if the forward forces and backward forces cancel out for a moving body, then the object will remain with that constant velocity. So in other words, if the forces backwards and forwards cancel out, and this object is moving with constant velocity, it means that that object will have no acceleration, and therefore that object will remain with that constant velocity. Again, if the forward forces are greater than the backward forces, then the moving body will speed up. What it means is that, for example, if the object is moving and the force here is greater than the other force, maybe this is 10 newtons and this is 20 newtons. It means that the resultant of that this object will move in that direction. It will speed up actually. And if the forward forces are less, this object was already actually moving. If this object is moving and the forward force actually now reduces to 10 newtons, and yet the backward force, that this object is moving in that direction, and the backward force actually is 20 newtons. It means that this object which is moving, it is going to slow down. Newton's second law states that if the resultant force or net force acting on an object of a certain mass is not 0, then the object accelerates in the direction of the force. This is very important. Acceleration is in the direction of the force. And that is if the resultant or the net force or an unbalanced force is not 0. And so the implication is that the acceleration of an object when the force is increased, actually, the acceleration of an object when the force is increased, it decreases when the mass actually increases. In other words, what we are saying is that acceleration is directly proportional to the force. When acceleration increases, similarly, force increases. However, acceleration is inversely proportional to mass. When acceleration increases, then the mass actually reduces. And when the mass increases, acceleration reduces. And so the actually formula which links this now is that actually force is equal to mass multiplied by acceleration. This is a very important equation according to Newton's second law. So it is actually Newton's second law where we find the equation force is equal to mass multiplied by acceleration. And force here would be in newtons, mass would be in kilograms, and acceleration would be meters per square seconds. And so the explanation is that when more people actually go into a bus, it means that you increase actually if this car is moving and you add in more people, it means that that car is going to have more mass. It means that the mass will increase. And if we actually, the force from the engine actually, we say it remains the same, eventually what you will find is that actually it will be very difficult for you to gain more speed because of the increased mass. So the object will not actually easily accelerate. So in other words, it means that when you increase the mass, the acceleration actually reduces. As we said, these are inversely proportional. Newton's third law actually states that when a force is exerted on a body, there is an equal but oppositely directed force. What it means is that if I have a book here on a table, it means that this book actually has weight. And if it's not moving up and down, it's just stationary, which means that there is another opposite directed force, which is actually known as the normal force. So this normal force will be the same as the weight because this object is not moving either upwards or downwards. In other words, what we are saying is that if you exert a force, which we can call, you act a force, you are going to produce an equal but opposite reaction of the force. So here, the action would be weight and the reaction could be the normal force. And so here is a simple question to actually link to what we were just discussing, in particular, the second law of Newton. When a stationary at rest object is pushed horizontally, its velocity increases actually to 30 meters per second in 3 seconds. Find the magnitude of the force acting on the object. The first thing we need to know, we need to gather data of what is given in the question. So the first question we are given is that the object is stationary or it is at rest. It means that initial velocity is actually 0 meters per second. The other thing we are told, actually, this velocity after the object starts moving horizontally, the velocity increases to 8 meters per second, meaning that our final velocity is equal to 30 meters per second. And the time it took to increase this velocity from 0 to 30, it took actually 3 seconds. So now they're asking us to calculate actually the magnitude of the force acting on the object. We are aware that we have this model equation in Newton's second law, where we said force is equal to mass multiplied by acceleration. So what they are asking us to find is actually force, give a question mark. And therefore we have to calculate, and we are given actually the mass of this object, which is actually the mass of the object actually is 20 kg. A stationary object, the mass is 20 kilograms. 20 kilograms. And so we can calculate the acceleration. So what we don't know here is the acceleration. And therefore we can say acceleration is equal to final velocity minus initial velocity over time, which gives us actually 30 minus 0 over 5. Over 3 seconds. It's 3 seconds actually. We are told that it's 3 seconds. And so this gives us actually 10 meters per square second as our acceleration. And therefore force would be equal to mass multiplied by acceleration. And we are told that the mass is actually 20 kg. So 20 multiplied by 10 meters per square seconds. It gives us actually 200 newtons. So basically, this is how we can make use of Newton's second law to calculate actually force. So for those of you who want actually one-on-one lessons, you can contact me on my WhatsApp number, which is plus 26097741199. And then we can actually deal with more questions on Newton's first law, second law, and third law. I thank you.